Okay, thanks, Jody and Josh. I believe I've started sharing my screen, so I'll just jump right into it. Let's start this slideshow. So we already introduced what I'll talk about today, so let's just jump right into the presentation overview. So like Josh mentioned, first I'm going to introduce the project I've been working on in my postdoc briefly, and it's a Karuk tribe-led project. And Berkeley, we're just helping out with that project. And it's focused on Roosevelt elk habitat and populations within their ancestral territory in Northern California. So in the spring, I built our Shiny app as part of a course run through Succinct that I highly recommend. Dennis said that they may run this course again next year. So keep an eye out for that. Might not be through Succinct, but that was really helpful and really advanced my understanding about Shiny very quickly. So I built this app as part of that course, and with the idea that it could be used as a decision support tool by the Karuk tribe, kind of to help support fire, prescribed burning, and wildlife management. So here's just a quick screenshot of what that app will be, and I'll do a walkthrough of that app in the near future. But then part two, I'm going to stay in the same study system, but I've uploaded some dummy data that we'll be using. It's not real elk presence data, so there's no worries about that sensitive resource. And I'll be just live coding in RStudio, so we might run into some live errors and common pitfalls that I make, and hopefully that'll be useful too. All right. So to introduce the study system briefly, Roosevelt elk in the Klamath were actually extirpated in the 1800s. I think the last elk in Siskiyou County were seen in the 1870s. Mostly this was a result of overhunting. Once Euro-American settlers reached the area in the gold rush, elk were pretty quickly hunted out and also killed because of foraging on agricultural crops as retaliation. Another big factor is that the Karuk tribe has, since time immemorial, been doing a lot of management on their landscape, and a lot focused on traditional fire practices. And some of those management practices were focused on improving ungulate habitat, so for deer and elk. And so when the Euro-Americans arrived, there was a lot of persecution, and eventually those fire practices were completely outlawed by U.S. government. And we're just now kind of starting to get back into the prescribed burns. So a quick map of this study area here. So you can see we're in Northwest California, just inland from the coast. The blue line is Karuk's ancestral territory. These orange and red lines I have on here are both existing and planned prescribed burns. And this kind of furthest inset map on the right here is our main study area for this project. So most of our elk data comes from this area. Okay. So one of the big questions in our project has been, what are the effects of prescribed burn treatments on elk habitat? And we went about to answering this question through a series of methods that I'll just briefly describe here. So first, we fit species distribution models to elk scat locations collected in 2018, and using vegetation cover data remotely sensed at 30-meter resolution with Landsat data as our habitat predictor variables in that species distribution model. We then used that model to predict elk habitat suitability not only in 2018, but also in 2013, where we also had remotely sensed data available. And using those two predictions, come up with a change in predicted elk habitat between over those 5 years. So with that kind of change layer, we then fit spatial autoregressive models to predict that change based on the prescribed burns that were done over those 5 years in those areas, as well as some control variables that might affect the vegetation change, like elevation and terrain ruggedness and aspect. So to quickly talk about the prescribed burns we'll be discussing. So one of the main ones in the area is these broadcast burns that are kind of allowed to spread across the ground and the understory. So it's a little bit wider but low intensity burn. And then the other main ones we'll see are the hand pile burns and also jackpot burns. Both of those prescribed burn types are more concentrated burns of like gathered fuel, but not really allowed to spread. Okay, so what were the results of this? With little surprise to the Karuk, the prescribed burn patterns that done on the landscape that most resembled Karuk traditional ecological knowledge maximized elk habitat increases. So generally, these were broadcast burns. Karuk did a lot of these traditionally, and cyclical, like multi-year broadcast burns that were repeated in an area had some of the biggest increases in elk habitat. That's likely because elk are generally preferential grazers, even though they're generalists that can eat forage on shrubs as well. But they really like these open habitats with meadows, a lot of grasses and forbs to forage on. And so the broadcast burns kind of open up the availability for those conditions to come back. Just treating a site with hand pile or jackpot burns actually had a negative effect on elk habitat. But interestingly, we saw that mixed jackpot hand pile burns with then multiple years of broadcast burns, that had the highest positive effect on elk habitat. So probably some benefit of clearing the fuels and then having a broader understory burn. So that was cool to see, and good results for the Karuk tribe on this project. But how might we apply these results? So we've got a very specific study time frame of 5 years. So given current elk habitat conditions, we're able to maybe propose a prescribed burn plan in a given area and then predict what that would do to the elk habitat in another 5 years. So that's the power of this particular model. But to actually do that, it's super time intensive to learn, R coding, as I'm sure everyone here is aware. And then to, code out different treatment plans and predict those effects and try something else is just a lot to ask for managers, and even for us as study authors. This would take forever, changing that code one plan at a time. So that's where the power of a Shiny app comes in. And so I built an app, like I said, this year that allows the users to propose different prescribed burn plans in a given user-drawn area in our study system, and then predict the effects of that plan on elk habitat change. And I think it's a lot easier to comprehend and visualize with this Shiny app. And I've already gotten some pretty good feedback from the Karuk tribe, and that they're going to want to put this in front of, the burn planners, and so they can take into account wildlife and elk habitat in particular when they're making their plans. So as a decision support tool, I think Shiny apps can be extremely useful in actually connecting the science to the management. So I'll jump into the app right now, show you around it. Let's see, I think I've got everything loaded, so I'm just gonna hit run. And this is still a work in progress. I'm looking at using a dashboard layout right now that I'm kind of liking. So the app brings up an introductory page, tells the user about the app and how to use it. But since I'll be walking through it, let's just go right to the Explore Treatment Effects tab. So that's going to bring up this map on the top left box here. And as you can see, I've got a raster loaded in of current elk habitat suitability in the study area. And you can kind of see it's cropped. This is to the elk's winter range. So elk in this region are migratory, and we're most worried about their winter habitat. That's the most kind of restricted. So that's what this study was focused on. And we've got a background base map that people can, a manager could orient themselves on, the main highway, or the creeks or forest roads in the area. And the main functionality here is that once the user identifies a area they might want to propose a prescribed burn plan for, they go here to draw a polygon. So maybe they notice there's some lower looking habitat suitability in this area, so maybe they want to propose a burn in this polygon. And once they click this finish drawing, then a conditional panel pops up down here called proposed treatment. So they've got 5 years to propose, and they could leave it as completely no treatment. But based on study results, we know that generally the multi-year broadcast burns seem to have a good effect on elk habitat. So let's propose a couple years of prescribed broadcast burns. And then when they click predict change in habitat suitability, on the server side, it's predicting our model, clipping the rasters to this polygon, and then outputting those predicted habitat changes and zooming right to it in this box here. So right away, the user can see, okay, there's pretty high predicted changes in the habitat based on that burn plan. And then there's also a little table we spit out to give them a summary of the minimum, maximum, and mean predicted change. So that's where the app is at now. Already, I think, pretty useful, but we're hoping to add some further functionality like a download of the results and the proposed, polygon. So if they wanted to, a prescribed burn manager could, download this to a GPS and give it to their field crews, and they could directly start the burn plan with that. So that was the run through, and I'm happy to talk about this app more later if you want, but I will jump into the second part of the webinar for now. And before we get coding, I think perhaps everyone has some functionality or knowledge of Shiny, but I really liked this overview slide from Josh's seminar earlier in the year, and I just kind of stole it because it's a great one to just refresh what Shiny is about, I think. So say you publish a Shiny app to the web over here on the left, and hopefully we've coded a nice user interface for the user to look at and make some selection on the app. And then that's pushed to the server, which can perform some calculation or maybe render a map working with Leaflet. And it will return that to the to the user interface and present that to the user. So pretty simple overview, but I think what I struggled with most, getting started with these apps is just figuring out how that connection was happening, especially with reactive inputs, how the UI was talking to the server. And to briefly introduce Leaflet, so it's an open source JavaScript mapping software. And if you've ever played around with like New York Times mapping tools, published, news pieces, that's all running on Leaflet. I think the Washington Post also uses Leaflet, as well as Mapbox. So a lot of different outlets using Leaflet, and that way it's kind of like a competitor of Google Maps in a way. Just another option. And there's really great functionality with Leaflet in R and R Shiny, which we'll be talking about today. And so that's a big advantage. And there's great resources out there for getting started with Leaflet in R and R Shiny. This is one of them. And if you're looking to learn more, I'd highly recommend going through those kind of intro exercises and documents. All right, so like I briefly mentioned, we're going to stay in the same study system with this kind of interactive coding session. A bit simpler data, dummy data, just elk presence data I'm going to upload. And we're starting with the very basic leaflet map, and then we're going to start adding that data and more interactivity in certain steps. So I believe all of that has been uploaded to the GitHub, so you can download each script. But if you want to start with the base app and work along with me, I'm going to try to do some live coding and go from there. And yeah, I'll just get to the RStudio. Okay, so if we start with our base app .r script, this is the basic, beginning, and these are the 5 packages that we'll need to progress to the last step that I'm hoping to get to today. But I'll briefly go over what's in this base app. So this is like the very beginning of just having a map. So we've got our UI, our user interface, and the fluid page is a common, like pretty nice layout that's easy to make for Shiny apps. So you'll see it a lot. And within that page, I've got a title panel. I'm calling it Map for Exploring. And our main page is going to be this leaflet.
I think Thomas froze.
Yeah, we might have lost him temporarily. So I guess we'll give him a second to connect again.
Oh, looks like I dropped off for a second there. Sorry about that.
You did. You were just starting in on your base code.
Okay. Yes.
The main page.
Oh, okay. So I haven't talked about server yet for everyone. Or let's see. Let me share the screen again. Okay, so yeah, hopefully this isn't repeating too much that I've just talked about, but we've got our main page, which is a leaflet output, and the UI is looking for an output from the server side. So that's going to be this map here. And as you can see within our server function, we've got an output $map. So that's what we're pushing to the UI. And that's a render leaflet function where we have our leaflet map, and then we're adding a very basic background map in this case with this add provider tiles function. And you can choose, there's a lot of different loaded background tiles, provider tiles, and you can quickly kind of search through those by just hitting $sign after providers, and there's a huge list here. But we'll just start with the default kind of first one, OpenStreetMap. So with this basic app, let's just see what it does. Haven't loaded any of our own data. We're just kind of loading a world map here. And already at this level, you know, there's some interactivity here. The user can zoom in, pan around. And so we might want to zoom over to our study area and start checking things out. But there's nothing else going on. So let's load some data into the global environment, and then start coding some stuff for the user to do with the data. So I'm going to load in the elk dummy presence data, and that's a shape file. So if you have the raster package, I think it's able to work with that using the shape file function. And let's see, I think I've called that elk.jittered. So if you've downloaded that, you can get that loaded in. And we can ignore the spatial warnings for now. We're just working with some dummy data. Okay, so let's take a quick look at that spatial points data frame now. So we've got longitude, latitude, and then a DAT SRC. That's a data source. So some of these points are coming from camera traps, hypothetically, and some of them are coming from SCAT presence locations. So first thing I want to do is add some functionality for the user to display different presence points based on where they came from. So the way I'm going to do that is in the UI, going to add a bit more. So after the title, we're going to do a sidebar layout. And so now there's going to be like a side menu and then a main display page with the sidebar layout. And so on the sidebar panel, I'm going to add a picker input. So this comes from the Shiny Widgets package, and I think it's like a nice kind of menu for people to select different options. And so we're going to have to call this input something for the server to read later. So the input ID, I'm going to call data source, because we're going to, have them choose either camera or SCAT. And for the user, we'll make a little bit nicer of a label. Just going to say select a data source. And then we're going to point to the actual file as to define their choices. So that way, if we update this file in the future, it's just going to search that data source column for any unique values and present that to the user as choices. All right, let's leave it there for now. And yeah, as far as common pitfalls go, I often get really mixed up with the parentheses, especially in the UI. So as you can see, I've opened a sidebar layout, and I'm already like, oh gosh, where are these errors coming from? So I think what happened here, this is a comma is needed to kind of end the sidebar. Oh, that's the sidebar panel. No comma here. Okay, I think we've fixed it. So you'll notice in the scripts that I've published for you, everyone, is I really like to hashtag out notes to myself and say, okay, this is where I'm closing the sidebar layout, and this parentheses is where I'm closing the main page or the sidebar panel. But for now, let's just keep going with the oops. Yeah, already messed up something with this input. So I'm just going to go ahead and jump to base app step 1. So we could see this is what it should look like. And in addition to defining those choices, I kind of wanted the user to have something defined for them at the beginning. So I'm in the picker input.
Oh no.
I'm specifying selected equals the camera points. And I also want the user to be able to choose both camera and scat or whatever other data sources might come in the future. So I'm specifying multiple equals true here, so they can select multiple things. Okay, so now we've got our user interface, but there's nothing yet on the server side to actually, subset out our data and then present that to the user. So to do that, we need a reactive expression here. So I'm calling that pres.dat_cell for selected data. Opening the reactive expression and then doing a simple base R subset here. So, and whatever is being subsetted, I'm pointing to that user input. So the input $ data source is going to have the server look for this picker input, which, we've defined our input ID up here. So that's what the server is looking for. So we're subsetting that out and then returning the resulting data set in this reactive expression. Okay, so moving on to the actually showing this to the user. We've piped in another line here after the base map, and we're adding circle markers for the points. I think those work pretty well for any kind of point shape file. And we just, point to the data. And another common pitfall is within these reactive expressions, you actually have to open and close a parentheses to point to what you're returning inside there. And for color, if you remember when I hit head, I've kind of pre-computed what colors I want the scat versus camera data to be. So I'm just pointing to that column here. So you can see there's a column called color. And so that's what the circle markers function is going to look for to color these points. All right, then finally, I think every map should probably add scale bar, and just the basic scale bar in Leaflet is really nice. It'll update, if you're zooming in or out to help orient the user a little bit better. And then finally, I'm also adding a very basic legend for the user, just to be able to differentiate what the green and blue circle markers are actually representing, which is the camera and scat points. Okay, so let's see how it looks after we've added all this. All right, so now we're zoomed into the camera points because that was our default menu option we defined. We can add scat points, and we can see, the legend is telling us which are which. And those markers are kind of automatically updating as well as we zoom in and out. So some pretty cool functionality, but we're still, basically some kind of a GIS application here where we're not really running anything in the background. And the true power of the R Shiny apps is that, the whole host of open source R packages out there are available to you to run on the server side and do whatever you want. So let's start adding a little more functionality, bring in some spatial packages and do some work on the server side. So I thought it'd be cool to add the ability for the user to buffer these points. by a certain distance that they may want, and then click a button to create the buffer, and then present to them what that buffer looks like. So in order to do that, let's start on the UI side again, our user interface. And I'm going to add a what's called a slider input. So that's going to define for the user how far they want to buffer those selected presence points by. So back to live coding here. We're going to call it buff distance, something straightforward to use in the server later. And for the user, we'll label it something a little same thing, but just nicer to look at. And then we're going to need a minimum value, a maximum value, and a default. So this is in meters, which by default, which I'll keep that, the raster buffer function, that is. So we'll start with 0 meters. We'll say, let's let them go up to 10,000 meters for 10 kilometers, and we'll leave it at a default value of say 400 or so. So there's our slider input. But I don't want this to just be creating buffers whenever they, slide around on this input. I want them to, choose something and then have to click an action button to actually create the buffer. So let's add an action button to this sidebar panel. And we'll just call this create buffer for the server to read, and for the user, again, just a little bit nicer of a label. Okay, so I think our UI should be nice and updated, but now let's actually start using those user inputs on the server side. So now we're going to need to create an event reactive. So this function is relying on both this presence data reactive data set and also on the user clicking that action button. So we'll call this one a presdat buffer, and let's make it an event reactive that's going to rely on a couple things I just mentioned. So we've got our presdat cell reactive data, and also the input of the user clicking create buffer. So once those conditions are met, this code will run, and we're going to put that buffer function from the raster package in there. So we'll say presbuff is, and I always like to specify the raster package. I've run into problems with other packages having buffer functions and messing me up before. But we're only going to buffer what data the user selects. So we're going to once again point to that reactive data set, and then we're going to buffer it by whatever that slider input ends up being. So the input $ buff distance, and then we'll return that buffer in this event reactive expression. Okay. So that's all in good, but we're still, once again, not presenting that to the user in the leaflet map. We have to add that functionality as well. And instead of adding that to the map it's directly within this render leaflet, I'm going to create an observe event and just add, instead of redrawing the whole map, we'll just add to the existing map. So that should really streamline things. So here's our beginning of our observe. And I'm also going to add a couple requirements to this observe event. And that's because if you don't require, for example, that action button to be clicked, you can run into some errors where it's trying to add this buffer line that's not there, and it'll crash out. So let's require the action button being clicked. Buffer. Let's also require that there be some data at all selected, because we don't want to run a buffer on nothing and error out that way too. So the way I'm going to do this is just look at the number of rows in our reactive data set, make sure that's more than 0. Okay. And after that, we'll finally open up a Leaflet proxy. So this is, like I was mentioning earlier, not creating a new map, just adding to our existing render Leaflet function map. So that's why we specify this map here. And let's pipe in the actual addition of the buffer lines. So first, I want to actually clear any previous buffer lines that are drawn, because I don't want the map getting super messy with a ton of different lines every time the user proposes a new buffer. And finally, add polylines pointing to that event reactive data set.
I think Thomas rose again.
Yeah. Hope he comes back pretty quick.
Okay, hi everybody. Sorry about that. I've switched to my phone hotspot because something is going on with the Wi-Fi. I hope this still is enough bandwidth to present this. So I think we left off where we had just tried to code out the buffer addition of a buffer distance to the leaflet. And so let's just go ahead and run that. Okay, so now we've got our slider input where we can drag, the user can drag this circle along the bar to propose a different buffer distance. So maybe they want about a 5,000 meter buffer, and maybe they want that with just the scat points. So they can come in here, click the create buffer, and then there we go. That triggers all the reactive expressions, and this buffer is created and presented in the leaflet map. So we're getting to some pretty cool functionality here. Maybe the user is trying to select some area to run a species distribution model and needs to understand the background conditions, and they might hypothesize that some distance around the presence points is a biologically meaningful background area. And it's like an easy way to explore that visually. So there we tried a slightly smaller buffer. All right, so before I end the talk, I wanted to take one more step, but a couple more complicated lines of code are needed in this. So instead of typing this out in the interest of time, I'm just going to jump right to the final step of this base app. And what I wanted to do here was use some of the cool functionality that Leaflet has directly on the render Leaflet function, and particularly allowing the user to draw certain shapes that can then be read and used on the server side. So let's see, I'll start down at the server here. So what I've done is in our main map output, I've added a draw toolbar as the last option. And so a lot of lines here, but mostly this is just getting rid of some of the drawing options. I just want like for my prescribed burn app, I just wanted them to be able to draw polygons. So I've set that as true here. And so that, I'll just show that real quick. That immediately brings up this drawing option on the leaflet. So here we go. There's a draw polygon option, and like in the burn app, the user can select points and then finish the polygon. But we still haven't added anything for the user to do with that. So I thought it would be cool if we were letting the user propose a polygon and then cropping the presence data to that polygon. So to do that, and on the server side, we actually need to access that whatever the user has drawn. And that I found to be a bit complicated. There may be a better way to do this that's prettier to look at, but I know that this at least works, where the user's drawn polygon is actually added into the input as map draw new feature. And we can access the geometry and the coordinates of that shape. And if we do that on the server side, we can, of course, start working with that data and do whatever we want within R. So I'm basically going through the rather complicated steps to make an SP polygon from the SP package, spatial polygon. And so at the end of this step, we have our spatial polygons. And then I just wanted to run the basic crop function on whatever presence data has been selected by the user, and crop it to the polygon that they drew. So that's kind of a long, a bunch of lines to get to this somewhat simple result within an event reactive. But it is a cool feature that you can do with Leaflet. And once again, instead of adding that to our main render Leaflet function, we're going to do an observe function where we require the user to hit an action button that we're going to create. We need there to be something in that data set, cropped data points. And once there is something, we'll open up another Leaflet proxy to that main map, add the circle markers, and just color them purple so they can differentiate from the main green and blue points. Okay, so just to quickly show what that looks like on the UI side, let's scroll back up. So I've done at times when maybe there's a lot going on in the Shiny app and you don't necessarily want the user to see all your menus until they have started interacting with the app. So this conditional panel I've coded to show up once the user actually draws a polygon and clicks finish. So that condition is met here by this output.crop on the server end. And just to show you how to add that, it's just an event reactive that looks for that drawn map feature and then sets crop to true once it happens. Okay. And then once that happens, we just have another action button pop up conditionally to begin that crop series of functions. Okay, so finally, let's see what the end result is. Go through the whole process. So yeah, maybe the user's interested in just the northern end of the study area and just the camera data. So they might just want to crop out those data like so. They finish their polygon, and then up comes this conditional button that says crop the data to the polygon. And here we go. We've got our cropped points, and those are presented to the user in purple here. So that's about all I had. I wanted to go through some of the cool functionality that Leaflet has. I'll definitely be available for questions as long as I'm needed. Thanks a lot for coming, and I'm sorry for some of the internet problems I had. I hope that it's been somewhat cohesive and useful. Let's see, I'll stop my share for now.
Well, thanks, Thomas. That was a great presentation. I'll see what questions we have at the moment. The first being what function is, or what package is this, the shapefile function in that you were using?
Oh, yeah, that should be in the SP package, but raster should load that. I always like to load raster because it loads some other dependencies. So yeah, if for some reason that's not working, you could try just to load SP directly. I think it's in there. And while I'm talking also, if there was a part that I thought I was presenting, but I was, dropping out, please let me know. I can go over that real quick if that was unclear.
Maybe it would be helpful to tell folks about some of the conflicts that you mentioned briefly between like raster and SP and other packages, and how you figured that out, that was an issue.
Oh, sure. Yeah. So once in a while, you'll try to use a function and be expecting some outcome, and it just is completely not what you were expecting, or just errors out by default. And when that happens, I just like to specify exactly what package I want to call from by typing out the package and then the 2 colons, and then it'll know R knows to look for the function within that package that you're using. But yeah, there's a lot of cases where there's like 5 different packages, using, as an exaggeration, the same function. So it's good to watch out for that.
Well, I think that was the only question. Well, no, there's another one. Okay. Will Leaflet work with the Terra package and SF? Do you know?
Yeah, I think you can. Well, so I don't know anything about the Terra package, so I can't speak to that. But SF, it'll definitely work. You can do a lot. I think, Josh, you were using SF and Leaflet in your presentation, and SF2 I think is gaining a lot more popularity more quickly than SP. I've just traditionally used SP more than SF because of its easy compatibility with the raster package, which has like just a ton of cool spatial functions for rasters and also vector data. So that's why I've been using SP, but I think SF would work just fine for most, if not all, of the functions.
Yeah, I think my experience is that SP, I think, has a little more functionality is supported better by Leaflet, and SF, you gotta kind of rig things up a little bit sometimes. So that was just my experience trying to do that stuff. Okay, there's another question asking regarding your last R script to step 3. Is it using the draw_stop event to detect when users are finished drawing, or just the action button, the begin crop?
Okay, let me bring up that step 3 script. Okay, sorry. So the question was, what is it looking for to detect when the user stops drawing? Was that?
Yeah, so is it using the draw stop event to detect when they're finished, or like if you have to click an action button for it to detect that it's done?
Oh, gotcha. No, you don't have to click an action button directly. It kind of, when you click finish within the draw toolbar, it registers that as the end of the user drawing. And you can access that with, well, okay, yeah, that's I guess a good point I should have gone over a little bit more. I was a little rushing at the end, but so the way to, hold on, let me share my screen again. So in my case, so the user clicks finish, and it then I have an event reactor an event reactive that is looking for that in the input. So that's stored here, the input $ map draw new feature. So and then I have it so that when the user clicks finish and it's logged in there, I have this kind of conditional crop equals true come up. But I guess that's only needed because I wanted to have the conditional panel. If you just wanted the button to be up there, you don't really have to worry about, registering on the server side when the user's finished drawing through some reactive like this. Yeah.
All right. I think that might be all the questions from Poll Everywhere. I guess if anybody else has a question, feel free to ask if you want, or add it to the chat or Poll Everywhere. Have anything last minute?
Yeah, since we're at the top of the hour, people can feel free to leave if they need to, but we can also open it up if anyone has questions.
Yeah, it looks like there's some talk in the chat about the succinct class that I took, and I'll just put another plug in for that. That was run by Dennis and Lindsay, who are here. There was another guy helping too, I think. But yeah, that was a really good course, and hopefully they're able to offer that again through, if not succinct, somewhere else. Because I was never had touched Shiny before starting that workshop, and I was able to get to like what I felt was a pretty useful app by the end of it, and that was focused on decision support tools, which I think is such a powerful use case for Shiny.
All right. Well, if that's it, then I guess we're done. Just thank you again to Thomas for rounding out this webinar series, and hopefully we'll be able to have some either future webinars or a short course in the near future.
All right. Well, thanks a lot, everyone, for coming.